In a dark room, there is a small corked quartz test tube held in a 3-jaw clamp on a stand. The test tube contains a mixture of hydrogen gas, H2, and chlorine gas, Cl2. We are going to try to initiate the reaction of H2 and Cl2 to form hydrochloric acid, HCl, by shining light onto the mixture. What color of light do you think is highest in energy and is most likely to initiate this reaction? Let's see what happens when we shine different colors of light on the test tube. Daniel first uses a small LED flashlight that emits red light or red photons. No reaction occurs. Then Daniel uses a much brighter red light source to provide more red photons to the mixture of gases. There is still no reaction. Next, we see what happens when we use green photons instead. Green photons have a shorter wavelength and higher energy than red photons. Daniel shines a green LED flashlight on the test tube. There is still no reaction. What happens if we try using a much brighter green light source to provide more green photons and shine it for a longer period of time on the mixture of gases in the test tube? There is still no reaction. Next, we test blue photons, which have a shorter wavelength and higher energy than green photons, by shining a blue LED flashlight on the test tube. There is still no reaction. What happens if we use a much brighter blue light source, which also contains higher energy blue photons than the one we used in the blue LED flashlight? The blue light initiates the reaction. This fast, explosive reaction drives the cork out of the test tube. Let's look at this in slow motion. The blue photons initiate the reaction by providing enough energy to a chlorine molecule, the Cl2, to split it into 2 chlorine atoms. The chlorine atoms then react with hydrogen molecules, H2, to form hydrochloric acid molecules, HCl, along with more hydrogen atoms. This fast reaction is called a free radical chain reaction. Let's watch it again from a different angle. Let's see what happens one final time at an even slower speed. Not only does the fast, explosive reaction drive the cork out of the test tube, it also propels the test tube backward in its stand.